So now I was flipping through my stuff and saw one of my old kits, component kits, had a relay in there. So right now the breadboard is not being powered. I'm going to turn the power on right here. So there's actually a switch. So that's the common terminal right there. And in this case it's ground. So that LED or that LED is going to make a connection over to here. So there's two other terminals up there. Right now it's connected to the lower one. And the thing is, we switch it electrically. So we have a coil inside the component right there. We have a diode because there's a coil. So when you put current through a coil and then you remove the voltage powering the coil, it actually keeps the current flowing for a little bit. So we got a diode here. There's the cathode. So we want to make that side more positive, that side more negative. Current flowing through it can go through the diode while it magnetic field collapses. We are going to switch it with a different power supply altogether. That is the main thing right there. So that's the cathode. I don't want to put negative there because if I put positive over on this side, well, negative is there, we will have a short circuit. So yeah, this is just a regular USB power bank right there. And we do have enough current for it to trigger, although the number is not showing up there. I don't know how long it will keep powering this. These usually shut off if you're not demanding enough current. But there, we switched it right there. And none of the power that is doing that switching, so this was the normally open position, that lower one. That means when there's no current flowing through the coil, that one's connected. When we put current through the coil, that's when you're not in the normal position, so it switches up there. It's switching down to ground. We're going from positive supply down to ground right there with the green LED. That's the main thing right there. So we got 5 volts. It's a 5 volt coil. We need to use 5 volts at the coil. This red LED only has a 220 ohm resistor, and therefore I am going to remove that because we're going to go up to 12 volts. So this is not affecting the coil at all. It's being energized by the power supply right there. I removed the power supply. You're not going to see it. That the alligator clip fell off. So I removed the power bank right there from the circuit, and the coil probably pumped a little bit of current through the diode right there. But otherwise, you know, we just de-energized the coil. Now it's switched back to the normal position. So again, we could use a higher voltage, much higher voltage, with the switching part of it. But the coil is set for 5 volts. We have to stay within those limits right there. And I'm going to put the red LED back real quick. And we'll see that you can also power it with the power supply. So this may have been a little too rushed for you. So we'll do a step-by-step build to take a closer look at it. But again, I don't want to put the negative side of the supply to that side, and I could just use a little breadboard jumper or something, or a male-to-male jumper to go in there, but I'm going to stick with the alligator clip because I got them right here. But now we can use the same power supply. That is perfectly fine right there. You just don't have to. Main thing is the power supply has to be set to the voltage of the coil. So right now this is a 5 volt circuit. We saw earlier we could use 12 volts. I'd remove the red LED though because it's not protected from 12 volts. Only 5 volts. But there you can see, now we are energizing the coil with the power supply. The green LED only needs 2 milliamps of current. That's what we were seeing before. And it might not be spot on 2 milliamps of current, but actually it should be. We got 5 volts, green LED drops 3 volts, 1000 ohm resistor. We'll let through about 2 milliamps of current. So I think we were pretty accurate with what we saw in there. And now we also have to energize the coil. That's about 40 milliamps of current. Remove the green LED right there. And now we just see the current going through the coil right there. And again, these two positions are completely separate. It's just one or the other is going to connect to that third pin down right there. We'll look at the pins coming up. And this does not want to separate. There we go. So right now, that green one is going to ground right there, and now the red one is going to ground. We have less current now because we're not energizing the coil. So now here is our 5 volt relay. You can tell it's 5 volts because it says, well, that's 24 volts DC right there. That is for the switching. It's the part number right there. So yeah, that L05V 5 volts right there. So that's for the inductor coil, and then the current that we switch there. So it says up to 120 volt AC. Of course, don't wire anything like that, but you can wire a 24 volt DC circuit. Limit the current to 2 amps. So apparently these pins can handle 2 amps. Now, we just used this side right there when it came to the switching right there. This is a completely separate switch. So there's 2 switches in there, and so both of their grounds are right there. Normally, the ground is connected to this spot right there, that pin above it. Same with this one right there, but it's completely separate. Whatever you wire over here will not be electrically connected over here based on these pins. And then when you energize the coil, get current flowing through the coil, it doesn't matter which direction, but of course your diode, your flyback diode, has to be facing whichever way you want it to be blocked when you apply current. Always remember that. But when current is flowing, then it will make a direct connection to that farther away pin right there. Pretty straightforward. So, while wiring this up, that gray jumper I got to ground. This is a bad spot right there. You can probably see it. So if I slide up one more spot, the green LED will not light up. That hole does not make a connection. So we're going to put the pin down here. But main thing is, I just have to line it up with this gray jumper right there. And so there it is. Make sure it's lined up, and we are locked into place. So 2 spots up is where the middle pin is when it comes to these 3 pins, and then 2 spots up again is where the other one is. So I just felt like putting red down lower, so we are going to go, we don't want to be in that spot. We want to go up 1, 2 right there. We want to be in that spot right there. Now the short lead, the cathode, is to our pin. Remember, the pins are 2 spots away from each other. Just make sure we line that up. And then the green one, the long lead, the anode, I want to be 2 spots above the red LED. Short lead, the cathode, down 1 spot right there. Now the short lead, the cathode, is to that top pin, as we saw before. And so 1000 ohm resistor to the positive supply. Just because green LEDs are so bright, use a relatively high value resistor to limit the current. Red LED needs more current right there, 220. If I wanted to make this a full 12 volt circuit, I could also use a 1000 ohm resistor with the red LED, and then like a 2200 or maybe even higher with the green LED. So we could always do that. Now we have that diode right there. So again, doesn't matter which direction we go. I want to work though positive left, negative right, so I'm going to keep it the way that I am. Again, positive to left, there's the cathode, the gray band. It'll be on the left side right there. And then no gray band, the cathode over there. When we get this negative, current cannot flow through it. It can only flow through the coil. But we remove power. Current wants to keep flowing in that direction. It can circle back through the diode. And so pretty sure that's usually called a flyback diode. Could be wrong. I haven't looked up the terminology recently. But there we go. We're just on the 2 sides of the pin, and this makes a fairly good way to make a connection with alligator clips. So we'll go back to the supply. Supply was off, and hopefully we wired everything correct. Turn it on, and the red LED lights up right there. And again, we can either use this power supply since it's set to 5 volts to switch it directly. I'll do this demonstration again. We got these power supply, and some of these power supplies, I think they have to get to like half of an amp, or they just shut off. And so this one might be like that. This one might stay on indefinitely, even at relatively low current. We saw earlier it was like 40 milliamps current. Main takeaway though is this is a completely separate power supply. The coil is not electrically connected to anything else over there unless you use the actual power supply right there. So again, I can power this at 12 volts. I'll remove the red LED. Just doing this demonstration again. Maybe it's confusing for some people at the beginning, but now that we rewired it, yeah, I can go to 12 volts. Now that we wired it step by step, I should say. Maybe it makes more sense to some people. So yeah, we lost connection. But yeah, there you can see the green LED turned off. But if I want the red one, I gotta use 5 volts at the supply. But we can have a higher voltage powering our switched part of the circuit while we have a lower voltage doing the switching. That is the main takeaway. Now I gotta remove this so that we go back to the normal position. So this is normal. The coil is not energized. These two are normally connected. When we energize the coil, that is the not normal state. So energized is, I can't think of any other terminology for it. When we energize it, that's not normal. So there's also normally open, normally closed. So this is normally closed right there. It's a closed circuit. They're connected. That one's open. They're not connected. And when I energize the coil, this time I can do it with the power supply because we have 5 volts. And the coil is what sets the current based on that voltage. So if you use a higher voltage, then you're going to get more current. So I think 6 volts will still be okay. I'm not sure the maximum that we can do. But there you can see current went up. It looks like about 10 milliamps more. So I don't know how high a voltage you can go before it causes a problem. Just try to use the voltage that they got on there. And once you do switch it, probably maybe 4 volts is still okay. So yeah, it stayed switch, even 3 volts. 2 volts though, well yeah, we don't have enough voltage to light the LED. I think that was the problem. It will break the switch at some point at a low enough voltage, and then you got to raise it up to get up. So yeah, I think now it's switched to the normal position. We don't have enough current. So yeah, you can see the red LED a little bit, faint glow, because we got such low voltage. Now we get up to 3 volts. So usually you need a higher voltage to actually switch it, and then so you got to lower it quite a way before it switches back. There's hysteresis built into it, just the way that the coil works. There's something else to consider. So in any case, didn't do a diagram with this one, although I'm pretty sure I have a diagram that would go well with this. And when I come across that again, I'll just remake the video with the diagram for those that like the videos with the diagram more. Otherwise, thanks for watching. Make sure you check out one of the other videos I posted to the screen, and check out links down below. They all help out a lot. I'll see you in the next video.